All right, hello everybody. We're going to go back now and add to something that we did in the previous units, which was, we talked about how to find equations of tangent lines. We have several ways of doing that now. We're going to go back in and add normal lines to that, as well as revisit the definition of a derivative and its alternate version. So that's the theme for the notes today. So we're going to touch on normal lines and also the alternate derivative definition. All right. So first, let's go through the definition of a normal line. Okay, and a normal line is simply the line that is perpendicular to tangent line. Okay, and that's really all you need to know. So questions might typically be something like this. So let's say we want to find the equation of both the tangent and normal lines to the function y equals 1/4 x to the fourth minus 2x cubed at the value x equals 2. Okay, and so just to give a picture of what's kind of going on here, you can quickly sketch a picture. It's a fourth degree, so it opens up. If you kind of look at the calculator, you can see that it's going to look something like this. Okay, and we're interested now at this point at x equals 2. So let's say 2 is right here. And so what we're trying to do is find tangent line equation. So that'll be the orange one. So this is the tangent line right here. And the normal line. So the normal line, by definition, it's just the line that's perpendicular to the tangent line. So this is what the picture looks like. All right, and we know how to find the equation of the tangent line. We just need two things, right? We need to figure out what point we're going to use, and we already know that x is equal to 2. All right, and you can plug in x equals 2 into the y equation. And if you do that, let's see, what do you get? You get 1/4 times 2 to the 4 minus 2 times 2 cubed. That's 16 times a quarter, which is 4, minus 2 times 8. So that's negative 16. 4 minus 16 is negative 12. I apologize for the noise. There's some construction going on next door. Wish they would have told me they were doing construction. Oh well. So let me now write that up here. So the point is 2, negative 12, and now we just need the slope. And we know that to find the slope, we can just calculate the derivative, right? So if we take a look at y prime, take the derivative of this function, so bring the 4 out in front, multiply, that gives you just 1x, and then decrease the exponent by 1, so that's x cubed. And now, same thing over here, 3 comes out in front, you get 6x, and then squared when you reduce the exponent by 1. So this is what we called, I think, a slope generator, right? This is the equation that gives us the slope or the rate of change at any point that we want to know about. And in this case, we want to know about x equals 2. So if I plug in 2, you get 2 cubed minus 6 times 2 squared. That'll be 8 minus 24, which is negative 16. There's my slope. Okay, so this is your slope. All right, and so the tangent line, use point slope form. We just do y minus negative 12, so y plus 12 is equal to negative 16, x minus 2. And there's our tangent line equation. And now for the normal line, you don't have to do any work. You just have to remember that if it's perpendicular, then the slopes are opposite and reciprocal, right? So if the slope here is negative 16, then the slope for the normal line will be the reciprocal and opposite. So 1 over 16, x minus 2. Nothing else changes except for the slope. All right? So that's a little bit of information about normal line, and that's really all you need to know. So you should be good to go with that. And now let's go ahead and revisit the definition of a derivative. So we know that f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, and it's important to note that this gives us the derivative function. All right, so if we want to know the derivative function, in other words, like for example, if I look back at the first problem that we did, if you want to figure out the derivative function the long way using the definition, you can apply this limit to this function here, 1/4 x to the 4 minus 2x cubed. Okay. Now, if we want to know, and so here's the alternate definition. And that's now f prime of a. So notice the difference. Instead of f prime of x, we have f prime of a. And so now we're going to have the limit as x approaches a of f of x minus f of a all over x minus a. Notice this is just the average rate of change. Okay, so we're doing the average rate of change from x to a, or from a to x rather, and we're making x get so close to a that, so here's the picture for it. Here's a, here's x. So if we find the average rate of change using slope, we find the slope between these 2 points. If we make x approach a, that means this x value starts to get closer and closer and closer to this point. And so now, when you take the limit, essentially, when we're not finding an average rate of change anymore, we're finding the rate of change at x equals a, which is what this means. Okay? And so this represents so this gives the derivative at a specific x value. Okay, so we'll do a couple of examples. And again, the point of these is usually not so much can you find the limit, because you're not going to, maybe you'll have one limit question about the derivative where you actually have to figure out the limit step by step and prove what the derivative is. Most of the time when the limit questions are in this format, they're in this format so that you can recognize, oh, it's just the derivative. I already know how to do that real quick. Okay, so for example, we have the limit as x approaches 2 of 1 over x squared minus 1 over, let's say, 2 squared all over x minus 2. Okay, so look at the similarities between this and the alternate definition here. Okay, we have this looks like f of x. This looks like f of a. In other words, we plugged in 2. You see what I'm saying? And then obviously down here, this matches x minus a, x minus 2, right? So we can assume that f of x is this function right here, 1 over x squared. Okay, and so to avoid like actually finding the limit using analytics techniques and multiplying by common denominators and rearranging things and trying to get it to work out that way, we know that the function is f of x. We know how to find the derivative of 1 over x squared. Remember, if it helps, think of this as 1 over x squared equal to x to the minus 2. And so when you take the derivative of this, the negative 2 goes out in front. This decreases by 1. And so this is really the same thing as negative 2 over x cubed. And so now this is asking us, essentially, in a roundabout way, to find the derivative of this function at x equals 2. So it's the derivative at x equals 2. And now that I have the derivative function, you can just plug in 2. So it'd be negative 2 over 2 cubed. So that's negative 2 over 8, which is negative 1/4. Okay? Let's do one more. So let's say we have the limit as x approaches 8 of x to the 2/3 minus 8 to the 2/3 all over x minus 8. Okay, it's got that same flow, right? This is your f of x. This is your a value plugged in. And so here what this is really asking us for is to find the derivative at x equals 8. And here's our function, right? Our function is this one right here. So that's going to be x to the 2/3. And we can apply the power rule once again. So we have 2/3 comes out in front. Reduce this exponent by 1. 2/3 minus 1, or 2/3 minus 3/3 is negative 1/3. And so if it helps, maybe you can think of the function as 2 over 3x to the 1/3. All right, and so now we just go ahead and find f of 8. So we got 8. Oh, sorry. All that noise was distracting me. So this is f of x. I am so sorry. And so f prime of x is going to equal this. Right? F of x was x to the 2/3. Apply the derivative. And so now we get 2/3 x to the minus 1/3. And what we're really interested in is figuring out, again, the derivative at 8. And so we want to find f prime of 8. And so that'll just be 2 over 3 times 8 to the 1/3. That's 2 over 3. 8 to the 1/3, it's really just the cube root of 8, right? So that's just going to be 2. And so 2 over 6, or 1/3, would be the solution for that. Okay? All right. And so let's just kind of compare old version at specific x values. Right? So for example, let's say we have the limit as h approaches 0 of x plus h to the 1/2 minus x to the 1/2 all over h. Okay? Remember, now we're using the first definition, the original one, which was f of x plus h minus f of x over h. So right here, this is your f of x. Okay? And if we want to figure out this limit, again, that just means find the derivative. So if you know a better way of doing it, which we do, you can do the shortcut. So use the power rule, we get 1/2 x to the minus 1/2. Now, at a specific x value, so let's go x equals 4. So the question would look very similar to this, but it literally is going to look like 4 was plugged in to this function. And so it'll still say limit as h approaches 0, but now it'll say 4 plus h to the 1/2 minus 4 to the 1/2 all over h. Okay, and so now you need to recognize, okay, two things are happening. One, it looks like f of x is just, again, x to the 1/2, but x is going to equal 4, okay? And we know that because it looks like 4 was plugged into x. And so, same thing here. We know the derivative of f is going to be 1/2 x to the minus 1/2. And so now all we do is figure out what this is going to be at 4. So we plug in 4. 4 to the minus 1/2. That's really 1 over 2. 4 to the 1/2 down here. That's just the square root of 4, which is 2. So 1 over 2 times 2 is 1/4. Okay? I know that was kind of quick. I apologize for the noise. But if you have any questions, of course, we can go over some of these details in class. All right, enjoy your days.